Okay, a few of you had emailed me questions about some of the homework problems involving trigonometric substitution, and I'm just going to go through two of them. There were a few others that people emailed me about, but one of the ones from the homework is essentially the general form that will solve several of the other homework problems. You can just plug in different constants. So I'm just going to go through that one, because again, that will just solve everything else. So first off, this is number 4, which was the integral of 1 over x squared times the square root of x squared plus 4 dx. And as far as it goes, when we look at it, if we kind of think about the tricks we know, it's not a trigonometric integral, so that's out. U substitution is not going to work because that's an x squared in there. That's an x to the negative 2 if we were to write it in the other form. I don't know how we'd get integration by parts to work for that. So really the only trick we have is, hey, these things are squared. That's the square root of a sum, kind of like the Pythagorean theorem, the distance formula. So yeah, trigonometric substitution should work. And as far as it goes, there are certainly formulas you can memorize where if the integral looks like this, then set up your triangle this way. If your integral looks like this, then set up your triangle that way. I don't actually have them memorized. I've mentioned that before because I prefer to just solve the problem. And essentially, you can set it up and the integral will work. Or if that doesn't work, you really just have to flip the two sides, and in particular, generally just the two legs, and solve the integral the other way. So there's a limit on the ways you can set it up. Ultimately, the one trick is, if this is theta, that radical right there, inside there, that's a sum, which means this has to be giving me my hypotenuse. If that was a difference, then it would have to be giving me one of the legs, because that's how the Pythagorean theorem works. A squared plus b squared is c squared. That's a sum, so that has to be c, or a form of c. If this was a difference, it would be giving me one of the legs, the hypotenuse minus one leg to get the other leg. So in this case, I know I want this, x squared plus 4, to be my hypotenuse, which then tells me my two legs have to be the square roots of each of these, x and 2. And again, you can either set it up as 2 here, x here, or x here and 2 here. And ultimately, both of them should be solvable, but a lot of times, just because of practice and what we're used to, one will work better than the others, which is kind of where the formulas come from. But for the purposes of this, just to keep it in line with how I just solved it before making this video, we'll go with 2 here and x here. Now it's just a matter of setting everything up. And as I've said before, I'm aware that from a substitution perspective, different people see and learn substitution in different ways. Both U substitution, to a certain extent, integration by parts, and this. I just kind of always do it the same way because it's the way I learn, so it's the way I have to do it. If you write your substitution slightly different, that is completely fine, as long as you can set it up correctly and solve the integral. So in this case, I need x. And generally before we said, I need to come up with a trig function, but I don't want to use the other side with an x on it. I want to use the side with a constant. So I have x and 2, so that's tangent, opposite and adjacent. So tan theta is x over 2. I solve for x. I get 2 tan theta equals x. Now I really just look through everything over there and see what I need. I actually don't need an x, but I need an x squared. So square this. And I get 4 tan squared theta equals x squared, just squaring both sides. I need a dx. To get dx, I take the derivative of this. So take the derivative of both sides. That's derivative of this is 2. The derivative of tangent is secant squared theta d theta equals dx. And then I need the square root of x squared plus 4. Again, trig function, I don't want to use a side with an x, so I use a side with a 2. So that's adjacent hypotenuse. Given that this is already written in terms of reciprocal functions, we'll go with reciprocal, which would actually be secant. So I get secant theta equals reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. the square root of x squared plus 4 all over 2. But then again, I need the square root of x squared plus 4, so multiply the 2 over, and to save space, I'll just do it in one line. Now I should have everything accounted for. And again, there's different ways to write this. Me personally, I just write it out long form because I tend to forget things. So on the top, I need dx. Dx is right here, so that's 2 secant squared theta d theta. On the bottom, I need an x squared. That's 4 tan squared theta. Then I need a square root of x squared plus 4, which is 2 secant theta. And now I've accounted for the dx times 1, which is just dx. There's my dx. There's my x squared. There's my square root of x squared plus 4. Just plugging in all of this. Different ways to write it. That's just the way I do it. Now simplify everything. The 2's will cancel, so I'll be left with a 1 over 4. So I'll pull that to the outside. Then I have secant squared over secant. So this secant will cancel one of those. And I'm left with a secant theta on top. My d theta is still there. And then I have a tan squared theta on the bottom. And now, as far as it goes, this is now a trigonometric integral. So it's simply up to how you choose to solve it and what you know. And there's different ways to go. We know occasionally I need different identities from trigonometry. In this case, if that's a little bit confusing still to solve, write it in terms of sine and cosine, because that's generally the ones we know best. So secant is 1 over cosine theta. Tan squared is sine squared theta over cosine squared theta d theta. And then this cosine will cancel one of those. And now we know how this works. There's nothing left on top, but this cosine will flip to the top. So I get cosine theta over sine squared theta d theta. And I am also aware, as I mentioned before, I know I'm doing this incredibly long form. When you know what you're doing, you can kind of shortcut some of this algebra and go quicker. I'm just writing every step so we're clear. And then it's 1/4. Now if I rewrite this, that's cosine theta over sine theta times 1 over sine theta d theta, which is then 1/4. Cosine over sine is cotangent theta. 1 over sine is cosecant theta d theta. Now that's just one of the integrals we have, antiderivatives we have memorized. Keep in mind though, this is the antiderivative of this is not cosecant. The derivative of cosecant is negative cosecant cotangent, which means I just have to pull an extra negative out. If it helps, you can create a negative here and pull a negative out there, however you choose to do it. But it means the antiderivative is 1/4 times negative cosecant theta plus c. Now, just simplify everything. Pull the negative out. I get negative 1/4. Here, I'll throw my plus c over here. And then cosecant, we said to do this. Just look at your triangle. Cosecant is reciprocal of sine. Sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So I get the square root of x squared plus 4 all over x. And it's always good because that's what I had in my notes when I solved it earlier. And I do stress, again, occasionally you could make a typo, you could set this up wrong or something like that. You could make some little algebraic mistake. I could just take the derivative of this to check to make sure I actually get that over there to make sure it's right. I'm not going to. To a certain extent, this looks really messed up. Like, I wouldn't know, I don't know how to say this nicely here. This is a messed up function, which means it should have a messed up derivative that looks like that. That looks like something I haven't seen before. The point being, if I got something really nice here, 3x as an example, for my answer, that has to be wrong because I know the derivative of 3x and I know how to integrate it. So I have to get some weird expression here, because that's why I'm using all this trig substitution, because it has to be some weird function that requires me to use it. So just kind of keep that in mind. The other one, oh, my research broke. And this is number 5, which is the integral of the square root of a squared minus x squared all over x squared dx. And again, like I said, this is actually the general integral for all of them. A is just a constant, so I could plug in any number there, which some of the other problems in your homework do. So we'll just do the general form, because it's the same way you solve all of them. But again, I understand u substitution, it's not going to work. It's not a trigonometric integral. Integration by parts, not going to work here. But I see the square root, I see the difference there of squares. So a Pythagorean theorem, a right triangle makes sense. So I draw my triangle. There's my theta. Again, since this is a difference, that has to be C, the hypotenuse, which means the hypotenuse here has to be A. And then one of these legs has to be X. And the other leg has to be the square root of A squared minus X squared. And there are different ways to set it up. We've already established that. And you can just, if you're unsure, try both of them and look at the integrals and solve them. In this case, again, I'm going to do what I did in my notes, which is a squared minus x squared here, and this is x here. Now, I do what I did before, use this to fill in everything there. First, I need x. Keep in mind, a is a constant, so trig function that relates those, I went with cosine. So cosine theta is x over a, which means x is equal to a cosine theta. I don't need an x, but I need an x squared. So x squared is a squared cosine squared theta. I don't need an x, but I need a dx. So I take the derivative of x. Dx is equal to a. The derivative of cosine is negative sine. So negative a sine theta d theta. I have the x squared and the dx. I just need the radical. So I relate this and this. Opposite hypotenuse, that's definitely sine. So sine theta is opposite square root of a squared minus x squared over hypotenuse, which is a, which means a sine theta is equal to the square root of a squared minus x squared. Now, take all of this and plug it in over there. And I get the integral of the square root of a squared minus x squared, which is a sine theta, dx, which is negative a sine theta d theta, parentheses, all over x squared, which is a squared cosine squared theta. Now simplify everything. There's a negative here, so pull it to the front. A times a is a squared. There's an a squared down here, so all the a's cancel out. On the top, I'm left with sine. So sine squared theta with the d theta. On the bottom, I'm left with a cosine squared theta. And now, different ways I could go about solving this out, but it's a trigonometric integral, so in this case, I'm going to let this be my u. Derivative of cosine is negative sine. We can account for all of that, but that means I have to write this. Let's see. Oh, no. This one, they're both even, so if we remember our trigonometric integrals, we have to do something a little different, because if this is going to be my u, cosine, du will involve a sine, but I have two signs up there, which means I have an extra sign. but I don't have a Pythagorean identity that will allow me to write one sign in terms of cosine, so I have to try something else. And in this case, still use the Pythagorean identity. Sine squared is 1 minus cosine squared theta. The d theta just sits there, all over cosine squared theta. Now, I'm going to do two different things at once. Well, I'll do them separately, I guess. First, just to get rid of this negative out in front so I don't forget it later, I'm going to factor it in, which will flip the order on top. And then I'm going to break this up as two separate fractions. So I'll end up getting, I'm going to reverse the order so it's positive. Cosine squared over cosine squared. And then minus 1 over cosine squared. So I pulled the negative in, which flipped the order on top, and then since there was only one term on the bottom and two on top, I wrote it as two separate fractions. But now, that becomes the integral of cosine squared over cosine squared, which is just 1, minus 1 over cosine squared is secant squared theta d theta. Now just integrate. Antiderivative of 1 with respect to theta is theta. Antiderivative of secant squared is tan theta plus c. Now just substitute everything in. We'll do the theta in a second. Tangent, tan theta is opposite over adjacent, which is the square root of a squared minus x squared, all over adjacent, which is x, plus c. Now I need to get theta, and there's different ways to go, but in this case, I want to maybe avoid that. So I'll write it here. That is adjacent hypotenuse, so I know cosine theta is x over a. Take the cosine inverse of both sides. Theta is equal to arc cosine of x over a. And now I have my answer. And again, like I said, this is the general form for several other ones you have for homework and ones we had questions on, where you were given an a value there, but the same process will work. Also keep in mind, if I had flipped the order here, this would have ended up looking slightly different. I might have ended up with an arc sine as opposed to an arc cosine. If I flipped these, because then I would use this is my x over a here, so instead of taking cosine inverse, I would take sine inverse. But as far as it goes, based on the questions I saw and from looking at your homework, yes, if you want to memorize rules, this is what it looks like, this is how I should set up my triangle, this is how my answer should be, that's fine, I'm completely okay with it. Personally, I just draw a triangle and either it works and I can get an answer. If it doesn't, I go back and I try flipping the stuff around. If it's a difference, these have to be the legs. If this was a sum, it would have to be the hypotenuse. Beyond that, you have a little bit of freedom on what you're going to do. If there are other questions about trigonometric substitution or other integrals or homework problems or whatever, feel free to email me and I'll just make more videos and go through them.